Quicksort algorithm. Yeah, right. Now the Quicksort algorithm I will write here. You can note down the Quicksort algorithm. L to R, leftmost and rightmost, we can consider like that, or you can consider low and H, it's left to you, whichever you want you can take that. So input, what you are going to take, a array from leftmost to the rightmost, defined by its left and right indices L and R. Now output, what we are expecting the output, array A L to R, that should be in a sorted in ascending order. Now we'll start with the algorithm. If L is R, L is less than R, what do you have to do? First you find the S element, the position of the pivot element. Via how you are going to find? You are going to find what? The partition algorithm. I will tell you what is this partition algorithm. We will call that function. Afterwards, what we will do, once we located the S element, or once we placed the S element in its position, then we are going to split the array into the two parts. That is, again we are calling with sort A of L to S minus 1, observe carefully, S to S minus 1, and quicksort A from S plus 1 to R. That means leaving S this side, that is L to S minus 1 and S plus 1 to R, two parts. Again we'll find a partition like that. Recursively we'll do until L is less than R. That you have to know. Now what is this partition? What we are going to do in this particular partition? That when it comes to the partition algorithm, note down everyone, we are sending an array, full array, L to R. Now first what we are going to do, let the pivot element be the first element, that is A of L. L is a leftmost thing, that is low. It will start with 0th element. So let the pivot element or P element will be the first element. Then I will start with L, and J will always start with R plus 1. Let it be. Then repeat I plus 1 until A of I is greater than or equal to P. Observe carefully. So when we should increment I? We should increment I until A of ith element is greater than or equal to P. Next, repeat decrement J from R plus 1. You decrement J until A of J is less than or equal to P. A of J is less than or equal to P. Right? Next, after doing this, what you have to do? Swap A of I, comma A of J. until, for above repeat, until I is greater than or equal to j. That you have to make a note. Until I is greater than or equal to j, you keep on repeating. Once I is greater than or equal to j, what you have to do, swap a of I comma a of j, again swap a of L with a of j, return j, return j. Now, so this is the algorithm. I think everyone have written the algorithm. Everyone has written the algorithm. Still you are writing? I will wait. Still you are writing? Write down. After writing you tell okay, then I will remove this page. Everyone, you have written? So I can go to the tracing now, right? Everyone? Right. Now, coming to the tracing. Now, you keep this algorithm with you aside. Take one empty sheet, everyone. Take one empty sheet into your hands. Take one empty sheet. With me, start tracing as I will trace. Then only you can practice. Otherwise, it will become a difficult, right? Right. Now take the elements. I will take the elements like this, everyone. 8, 1, 9, some 3, 7, so 4, let it be 2. So these many elements have taken, and I want to sort these many elements, right? Now take the algorithm, go according to the algorithm. Now while taking the algorithm, first always will come with whatever is there, means L and R. So L and R, as you know that the L and R indicates the leftmost index of the array will be L, and the rightmost index of the array or last one will be R. So once if you give a indices for this particular array, that is 0, 1, 2, 3, 4, 5 and 6. Now L will be there always at 0, and R will be there always here at 6. Right? Now what is the condition? The first condition is like this. If L is less than R, that is 0 is less than 6, condition is true. Get inside. S is equal to partition of A of L to R, that is entire array we are taking and we are going to the partition algorithm. Now come to the partition algorithm. In a partition algorithm, we are fixing P is equal to A of L. That is, everyone see correctly, I will make the first element as a pivot element. Now L is equal to I, right? Now I is equal to n. Now j is equal to r plus 1. That is, I'll write simply here 7 and I'll place a j here just for a sake. Right. Now get into the loops. Now repeat. First it will go with a repeat until statements. How it will works. It will enter to the loop first, and finally it will check with the condition. So that is the first thing. So first thing what happens, it will come inside. So next I is equal to I plus 1. I plus 1 means I will come to the next stage. See, you may have a confusion here. While doing with a while it's different one, and doing with do while it is different one. In a do while the condition will be checked at last and the condition will be in a reverse. Here also same thing, until condition is there, until that you have to get into the thing. Everyone listening, quite reverse, huh? Understood? Hello? A bit slow, right? 1 minute, just a minute. Yeah, now I'll back here. See, what I mean to tell you, we have made an initialization as usual, you know, that is L equal to the leftmost, that is 0, and R equal to the 6, whatever array you are seeing there. Now once 0 is less than 6 in a first function, that is Quicksort, there yes, condition is true. Now S is equal to partition of array, we will call the partition function. Now you come to the partition function. In a partition function, what we are doing, P is equal to A of L, that is first element. So I have written P at the 0th, that is 8. Now 8 will be your pivot element. Now I is equal to L, that is I am initializing I at a Lth place, and then the J at a R plus 1. I have written as 7, R plus 1. So R is at 6, R plus 1 means 7. Now repeat. Now what is this repeat and until loop? See, in algorithms, when you are writing a repeat and until a loop, this is like this. First we will enter into the loop, and later on we will check the condition. After checking until condition, until keep on repeating. Once it will becomes true, you come out. In while loop and all, what is it? If it is true, then you get into the loop. When it becomes false, you come out. So here what happens in repeat until this is the case, until you keep on repeating. Once until this condition is true, you come out. Now we'll see how it will be done. Now repeat I. First what happens, repeat means it will enter. I told you first no condition will be there. Now coming to the next repeat statement, repeat I is equal to I plus 1. Now whatever I is at 0, I made to the 1 here until A of I is greater than or equal to P. That you have to check. What is this A of I? A of I is here. What is the value of A of I? 1. 1 is greater than or equal to P. Everyone, 1 is greater than or equal to P. Loudly. 1 is greater than or equal to P. Yes, Antiyallo. Dada. Hey. No. 1 is not greater than or equal to P. Am I right?
Yes.
Everyone getting right. 1 is not greater than or equal to 8. Therefore it is false. Again I will be repeated. I will be I plus 1. It will come over to 2 position, means again condition will be checked. A of I, now observe carefully, A of I, 9 is greater than or equal to 8. 9 is greater than or equal to 8. True, condition is true means you will come out. You will come out means you will go to the next statement, that is repeat J minus 1. Observe carefully, first without condition it will work. That means J will come to R. Right, now again what happens, now I will check the condition. If A of J is less than or equal to P, that is whatever is there here, observe here 2, what is the element? Yeah, 2 is less than or equal to 8. 2 is less than or equal to 8. Loudly. True. Am I right? Am I right? True. True. Yeah, true. True means once it is true means it will come out. Am I right? Don't get confusion. Don't get confusion. See, in previous and all we are doing a while loop. Now, one thing. If you are confused, wait. If you are confusing, this is according to the textbook. If you are confusing, I will put a while loop. You are confusing with repeat until. See, repeat until very simple. I will tell you, quite opposite to the while loop. If it is true, you will come out of the loop. If it is false, you will repeat. Very simple. That means without condition, first you will enter to the loop. Then after, like do while. Then afterwards, at final, you are going to check the condition. Got it now? Anybody? Artha aita? In second. Yeah, second loop. Second. Yes, we are decrementing the j. You see here, everyone. Where is j? J is at r plus 1. Am I right? That is at 7 initially. J will be at r plus 1 above. You can see here at j is equal to, while initializing r plus 1 we have initialized. That means see, j will be at 7. Am I right? While coming to the loop, observe carefully. Without condition, first the decrement will execute. That is j is equal to j minus 1. That means j 7, it will become 6 minus 1. Am I right? Am I right? Yes. Right. Now a of jth element will be checked with p element. If a of j, what is the condition? If a of j is less than or equal to p, everyone, if a of j is less than or equal to p, that is a of jth element is, sixth element is 2. 2 is less than or equal to p element, that is 8. 2 is less than or equal to 8. Condition is true. True means come out of the loop. Once if you come out of, everyone, once if you come out of the loop, what will be the next statement? It is swap a of I and a of j. Am I right? Now you have to swap a of I and a of j. Now I'll rewrite this. 8, a of I is at this position, that is 2. Now 1 as it is you write down. Now you swap, that is 2, 3, 7, 4, 9. Any doubt you can ask. What you are swapping? You are swapping a of I, this is a of I and this is a of j. That is a of I is 9 and a of j is 2. So you are swapping a of I and a of j. Now observe carefully, what is a I and what is a j. Now I will be at 2 only. After just you have swapped the values, you have not swapped the positions. Am I right? So where will be the j? J will be at this sixth position only, that is j. Now I is greater than or equal to j. What is this? I is greater than or equal to j. That means I value is 2 and j is 6. 2 is greater than or equal to 6. Condition is false. False means again loop repeats. Now come to the repeat. Repeat I plus 1. Now increment the I will become to the next position. That is the third position it will come. Now until a of I is greater than or equal to p. What is here? 3. 3 is greater than or equal to p. 3 is greater than or equal to 8. Loudly. No means loop repeats. No means loop repeats here. Then I will be shifted to 7. Observe carefully. I will be shifted to 7. Now 7 is greater than or equal to 8. 7 is greater than or equal to 8. No, false. False means again I will be incremented. Observe carefully. 4. 4 is greater than or equal to 8. Again, no, false. False means, observe carefully. False means again you are going to increment the I. I will come to this stage. Now again you should check the condition. What is the condition? That is a of 9. 9 is greater than or equal to 8. 9 is greater than or equal to 8. Loudly. True. True means come out of the loop. That voice you can stop me, mute it. Yeah. True means come out. Now again come to the J situation. Now J should be decremented. J will come, observe carefully, J will come here. After you will check the condition. Now you check what is 4. 4 is less than or equal to 8. 4 is less than or equal to 8. Condition is true. True means come out of the loop. Now observe carefully. Swap when you come out. Swap a of I with a of j. What is a of I with a of j? I and j are at same position here. Getting or not? No. No. I and j. I is at 9th position and j is at 4th position. It has been decremented. Correct? No. Now you have to swap that two. How you are going to swap? You will swap like this. I and j. That is 8, 1, 2, 3, 7. Swap this 9 and 4. Right? Now let it be your I there itself and j there itself. Now check next condition. I is greater than or equal to, observe carefully, I is greater than or equal to j. Now I is greater than or equal to j. I is 6, j is 5. 6 is greater than or equal to 5. Loudly. True. True means come out of the loop. Then again swap a of ij means re-swap. When you re-swap, what happens? 1, 2, 3, 7 and 4 and 9. It will come back. Now observe carefully. Now next swap is swap a of L with a of j. What is a of L? A of L is very clear that this 8. Why? Because we have not changed L. We are changing only I and j. That you have to keep in your mind. So what is j here? J is very clearly we know that j is this. That is at this particular 4th position j is there. Now you have to swap 8 and 4. That is 4 will come here. 1, 2, 3, 7, 8 and 9. Now what happens? Return j. Return j means at this position. That means you will return 5. Once if you return 5, you will come back to the calling function. Go back to the quicksort function. Now you see the next statement. Now what you are going to consider? You will consider this part of an array and the next part. This is S. Now with the j will come and sit in S. Now quicksort L2 S minus 1 and this you are going to take. Are you getting everyone? Yeah. Entire thing you want me to tell once again? Hello?
Last part, sir.
Huh?
Last part, sir.
Where actually?
This last part, sir. Yes, sir.
That one, see here. Come back to the above step. I will start from here. Everyone, where I will start? I and j. This one until I is greater than or equal to j. Am I right? Am I right? Yes. This step. Now I is greater than or equal to j. I is 6. J is 5. 6 is greater than or equal to 5. Condition is true. Am I right? True means you will come out of the loop. Once you will come out of the loop, again you have to swap with a of I and a of j. That means re-swapping will be done. That is 4 and 9. Re-swapping you have to do. Again it will be 8, 1, 2, 3, 7, 4 and 9. Again your I will be here only. Observe carefully. Now what happens? Next swap is swap a of L. Observe the a of L. This is a of L. I and j only we are changing. L we are not changing. So that means a of L means it is 8. And you have to swap that with a of j. Where is j? J is at 4th position. This is j. So you have to swap that. That is 4 and 8 should be swapped. Once after swapping, 4 will come back to the pivot element and 8 will back to the jth position. Now what you are doing, observe the return j. Return j means the j position whatever is there that you are returning. J position presently is 5. You are going to return that. After returning means you will come back to the quicksort function. Now your s will become 5. Now you can see your s will become 5. Now below statement you can see here quicksort a of L to s minus 1, that is 0 to 4 you consider the elements 0, 1, 2, 3, 4. 0 to 4 you consider as one array, and after s plus 1 that is the 5 plus 1 that is 6 until the next you consider the other array. So this will be 6. So you consider the other array. Now first what happens, first it will come to quicksort a of L s minus 1. S minus 1 means again you are calling the same function, am I right? Now freshly if you take 4, 1, 2, 3, 7. Now this will become your array. Here L will become this 0, 1, 2, 3, 4. L will become 0 and R will become 4. Now again you will come inside. 0 is less than 4. Condition is true. Again you will get inside. Get inside means s is equal to partition function. Now taking this you will go to the partition function. You will repeat the same process. Now observe carefully. I will repeat once again. Now again coming to the partition function, what happens? Now this will be considered as a fresh array. Now again P will be identified as a pivot element, that is 4. Now I will be at this. Sorry, this is I and this is L. I is equal to L. J is equal to R plus 1. R is already 4. R plus 1 is 5. Now your J will be at 5. Now listen carefully. Repeat. Repeat means directly entering to the loop without condition. Then repeat. Repeat means directly entering to the loop. That is I is equal to I plus 1. That is, again I will write here. You can understand now clearly. Now again 4, 1, 2, 3, 7. Now your I will be shifted to 1. Right? Why? Because I plus 1. Without condition it will shift. First instruction, then condition. Now you come to the condition. Now you check the condition. If condition is false, loop will repeat. If condition is true, you will come out. If a of I, that is 1 is greater than or equal to 4. 1 is greater than or equal to 4. Listening, 1 is greater than or equal to 4. False. False means loop repeats. That means your I will be placed at where? Your I will be placed at next. That is 2. Next element. That is 2. Next loop repeats. That means you are going to check the condition. That is a of I is greater than or equal to P. 2 is greater than or equal to 4. False. False means again loop repeats. I will be incremented. Observe carefully. Next 3. That is 3 is greater than or equal to 4. 3 is greater than or equal to 4. Condition is false. Again loop repeats. I will be here. Now again condition will be checked. 7 is greater than or equal to 4. 7 is greater than or equal to 4. True. True means come out of the loop. The next loop is directly will come to the repeat and J will be decremented without condition. That is J is at 5th position. Now you can see here J is at 5th. Why? Because R plus 1. Now J will be minus 1 means J will come to 4 here. Right. Inama? Anybody? Doubt?
Six or nothing.
Huh? Nothing. Now a of j will be compared with p. A of j means 7. Now observe carefully. 7 is less than or equal to 4. 7 is less than or equal to 4.
False.
False. False means j will be decremented again. That is important. Now I will decrement j. See, I is here and j will become here. I will decrement j. Observe with above line. Now again what happens? 3. 3 is less than or equal to 4. 3 is less than or equal to 4. Loudly. True. True means you will come out of the loop. Now swap a of I with a of j. That is, observe carefully. 4, 1, 2, 3 and 7 will be swapped. That is 7 and 3. I and j will not change. It will be there only. Am I right? Next. I is greater than or equal to j. Now observe carefully. I is at 4th and j is at 3rd. So 4 is greater than or equal to 3. Condition is 4 is greater than or equal to 3. Condition is true. True means come out. Come out means after coming out, next swap statement is reswap. That is 4, 1, 2, 3, 7. Again your j and I will not change. That will be there only. Am I right? You will reswap. Now again another swap statement is there. Now observe carefully. Which is L? This is L. And which is J? J is here. Now observe A of L. That is 4. Your 4 will be swapped with 3. That is the jth element. Now what happens? You swap it. That is 3, 1, 2, 4, 7. Now this is your j. After swapping, observe the next statement. Return j. That is, what is here? What is the position? 3. You are returning 3 and s is equal to 3 now. The next what you are going to do? Next you are going to split the array into 2 parts. That is this part and this part. Now you are going to take this. Only these 3 elements. That is 3, 1, 2 now. Within this 3, 1, 2, within this 3, 1, 2, what you are going to do? You will fix L and R. That is 0, 1, 2. The 0 will be L, 2 will be R. 0 is less than, observe carefully now. 0 is less than 2, condition is true. True means get inside. Again, you will call the partition. Now, the pivot element will be A of L. That is, this is your P. Now, I, you are going to initialize at L. Now, J will be here for an essay. Now repeat, enter. Repeat I is equal to I plus 1. Now I will be shifted to the next, that is 1. Now it will check the condition. 1 is greater than or equal to 3. 1 is greater than or equal to 3. Loudly. False. False means loop repeats. Loop repeats means again 3, 1, 2. Your I will become here. Right, and your j is here, that is 3. Keep in your mind. Now again what happens? 2 will be compared. 2 is greater than or equal to 3. False. Am I right? False means your I will come to 3rd stage. And again what happens? Observe carefully. Again what happens? You are going to the condition. What is condition here? Here A of I, the element is not there. That you have to check. Here the element is not there. Not there means you will come out. Once if you are going to come out here, then what happens? J you are going to decrement. That is your first you will decrement j. This will become j will be decremented like this. From here 3 it will come, but I is at 3, j is come back to 2. Now you check. That is 2 is less than or equal to 3. Condition is true. True means Everyone listen. True means what happens? You will come out of the loop. Now swap, observe, swap a of I with a of j. Here 3 is not at all there. So you can't swap, you can't go above. So swapping with same position. Now when you come over here, I is greater than or equal to j, condition is true, come out. Again it will be at a same position. Now what you have to do, you have to exchange the 2 and a 3. That is, you will come to 2, 1, 3. Right. Now this will become your jth position. Now whatever the jth position is there, 2, it will come. Apart from 2, nothing is there. You are going to take only these 2. Now again you are going to fix 0 and 1, L and R. 0 is less than R. Again quicksort function, true. True means get inside. Now you are going to partition. Partition, again you are sorting these two things. After exchanging these two, it will become 1 and 2. Finally you see now 1 and 2, 3 replace back, 4 replace back, 7 it is already there, 8 it's already there, and 9. So finally 1, 2, 3, 4, 7, 8, 9 will be the values. So in this way the sorting with quicksort will work. So why the quicksort is an efficient quicksort? Actually, to say merge sort is one of the efficient. Why? Because in worst case also it will takes with the n log n and plus n into n plus 1. So in a worst case also. But coming to the quicksort, in a worst case it's going to be of big n to the power of 2, but in average case always it will comes with n log n. So this is the average case. So this is worst case. So this average case is almost all preferable. When is a worst case? When is a worst case you are going to give for that? The worst case when you are going to give already the ascending elements, if you are going to give already ascending elements, if you are going to give, simply it should take and partition, it will keep on repeating. That means 1, 2, 3, 4, 5, 6. If you give this as an input, then again what it will do, it will consider this as a pivot element, again incrementing the I, decrementing the j, again finding, again it will come. So this is one of the worst case which you can consider. Because of that, in average case, the quicksort will be always n log. Any doubt here?
No, sir.
Anybody? Anybody? Tracing definitely will be there. Tracing definitely will be there. You do only 2 tracings. That is enough. That is, first you will get one part. After that one part, you just do that one part, and then you can say repeatedly this partition will be keep on recursively called. Finally, the elements will be sorted in this order. You can write order. Not a problem. There is no need to go how many times it will do. For example, 3-4 times you can ask me the question, sir, 3-4 times we should trace the same. No, only 2 times you trace, that's enough. Means 2 part arrays, one main array and second left part array. If you trace, that's enough, I think. Then automatically the evaluator will come to know that you have you know the quicksort, right? Right?
Yes, sir.
Now coming to the next. Tell me. Any doubt?
Yes, sir.
Right.
So when it is not fulfilling the condition, there are not third element.
Yeah, that's why what condition we should put in algorithm. You can see the algorithm when you go back. Just I'll back here. I think you can see, right, and you can see the algorithm here. Everyone, Raman. I is equal to I plus 1, as you are seeing, until A of j is greater than or equal to P, and you have to put I should be less than j always. I should be less than j. Then only you increment, otherwise you don't increment. That add up will be there always in a I. Otherwise I will go out of the range. To do that in a programming, what in algorithm it will be not there. In programming, what it will be there, to validate that, we are going to give here two conditions, that is A of I is greater than or equal to P, and your A of I whatever is there, it should be here, you should give reverse condition. It should be always greater than or equal to j. Then only if it becomes false, then only I will increment. If it is true, once I is greater than that, means I will go to the third position or equal to that, you are not incrementing. You will stop at second position only. Raman, got your doubt?
Yes.
Yeah.
Actually, the second factor.
Yeah, there it's not a problem. Why? Because j you will keep on decrementing. You never cross this L. Why? Because when you cross I itself, you are going to check this condition. That is I is greater than or equal to j. That will not be a problem for you. Here. Are you getting? Huh? Raman?
Yes, sir.
Yeah. Now we'll back with, we'll come to the next one, very important thing, that is a binary tree. Yeah. Binary tree. Now, what actually this binary tree is? The binary tree is one which will have a root, always root will be there. For this root, there will be a left tree will be there and a right tree will be there, not more than that. That means a root, a parent will have not more than two childs. It can have a single child, it can have a zero child also, not a problem, but it can't have more than two childs. So that is a binary tree. Are you getting? Any doubt? You know tree. What is tree? You know. Tree is the one where the loops will not be there. So where a loops will not be there and it's acyclic, then we'll call that as a tree. You know that. But I can tell this is also a tree. For example, I will tell you. See, 2, 3, 4, and 5. Now this is also a tree. You can't tell, sir, this is not a tree. Yes, this is also a tree. And for all 2, 3, 4, 5, the parent is 1. But this is not a binary tree. That you have to keep in your mind. What is a binary tree? The binary tree is the one where it can have at most 2 childs. Not more than that. It can have a zero childs also. For example, I will write only 1. This is a binary tree. True. If I write like this, 1 and a 2, and this is a binary tree. Yeah, this is also true. Not a problem. So what maximum we can write? You can write a maximum, that is 3, and for this here you can give 4 and a 5 like this, and then here you can give 6. Now this is a binary tree. Yes, this is a binary tree. You can observe in this entire tree, you can see there is no parent with more than 2 childs. So this is very much important. So this is a binary tree always. Now, according to your syllabus, you are having the properties of a binary tree. So definition of a binary tree and properties of a binary tree traversals especially. There are 3 types of tree traversals which are there. If you consider a binary tree like this, and how you are going to traverse from root to the leaf nodes. Always we'll call this as the first node as a root node, and the last one, this we'll call it as leaf nodes. And here between nodes we'll call, and the height of a tree we are going to tell based on the length what is you are going to take, that is how many parents are there, grandparents are there. So 5 3 for 3 is 1, so again it will takes around for 5 if I take one grandparent is there means automatically 2 will be the height. So like that which you can consider. So this is on a binary tree. Always any tree you can find a height, not a problem, but especially binary tree you have to underline the definition, that is at most only 2 parents will be there, not more than that, at most. That means 0 children can also be there and single child can also be there, not a problem. Coming to the next, the traversals. I'll come to the traversals just a minute. Yeah, I'll come to the traversals here. There are 3 types of traversals are there. That is, the first one is in order. The second one is pre-order. The third one is post-order. What is this in order, pre-order and post-order? These are the traversals methods which we are going to use. What is traversal? For example, always we'll start at root and I want to traverse all the vertices or all the nodes of a tree. Then what I should do? Which method I should apply? So the methods are 3 methods here: in order, pre-order and post-order. That means to traverse on all the vertices of a binary tree, we are going to use these 3 methods. Now we will see how these 3 methods will work. Coming to the first method. Yeah, coming to the first one. Now I will what is that? In order. Now you see the in order traversal, the word traversal. That means using in order I can traverse entire tree. You see the algorithm in order. What is the input? Input is your tree. So you have to give input as a tree. What is the first step? The first step is traverse the left subtree. That is call. Observe carefully now. In order left subtree of the tree. Next, second, visit the root. Next, third, after visiting root, traverse the right subtree now. Right subtree. That is what you have to do. Call again in order function you have to call recursively. Now you give the input as a right child or right subtree. It is right subtree. Close this. Right. Now this is the algorithm. In exam you have to write a algorithm like this. This is the algorithm for the in order traversal. Now you take a tree. Now previous whatever is there, you take a same tree. We can traverse, and I will show you how you can. 1, 2, sorry. Yeah, 1, 2. I'll rewrite. 1, 2, 3, 4, 5. And 6. Right. Now see the above algorithm. What is there? Traverse the left subtree. Now I am at root. Now I am here. Now traverse the left. What is left subtree for me? For me, the left subtree is 2 and 6. That means you come to 2. Once I will come to 2, everyone, when we will come to 2. Next, what is there here? What is there here? Traverse the left subtree. This is recursively it will go. Traverse means I will come to 2. For 2, any left tree is there? Yes. What is that left tree? That is 6. Yes, you come to 6 now. Once you come to the 6, observe carefully. Once you come to the 6, then any left child is there to 6. You have to traverse. No child is there. Now what you have to do? Visit root. What is the root of 6? Now that is 6. Write 6. Are you getting, everyone? Write 6. Now go to the right child of the 6. What is the right child? Nothing is there for a right child. Now, okay, 6 is enough. 6 is called by, everyone, 6 is called by 2. That you have to keep in your mind. Now come back to 2. Now from 2 I have called the left child. That means you can see here. From 2 I have called this 6. Now when I called back to 2, already this statement is over. Second statement, that is visit 2. Write down 2. From 2 you check any right child is there. No, right child is not there. Are you getting what I am telling you? Right child is not there. No right child. Now the 2 is called by 1. Now go back to 1. While from 1 when I called, I am at the first stage, I called 2. Now I came back. The next statement is visit root. That is 1. Write down 1. Now see the next statement. The next statement is traverse the right subtree. You come to the right subtree now. Now you have to come to 3. I will come here. After coming to the 3, for 3 you check whether the left child is there. Yes, left child is there. Come to the left child. At 4. Now you check again for 4. Left child is there. No means you'll come to the next statement. Visit root. Now root is 4. Write 4. Now you check again, right child is there to 4. No, 4 is a left node. No right child is there. Now what you have to do? Again go back to the parent called function. The called is 3 here. Now when 3 called the left, the next statement is visit 3. Write down 3. Now for 3, what is the right subtree? For 3, the right subtree is 5. You come to 5. Now again you check for 5. Any left tree is there? No, tree is not there. Now again the second statement is 5. Now again after visiting 5, what is the next? Traverse the right child of 5. Nothing is there. Are you getting? Nothing is there. So once here nothing is there, which is a called function? 3 here. 3 is already visited. We have returned. Now next, 3 is called by 1. Go back to 1. Now you have gone back to the main called function. From here you will come back to the main function. Now what is the traversing you have did? You have did 6, 2, 1, 4, 3, 5. This is in order traversing. Anybody not understood, you can ask me. If you want once again with another tree, I will tell you. Anybody? No, it will take another 5 minutes. I will tell. I will take another tree and I will tell. Huh? Answer me. Huh?
Sir, after 1, we have gone to from 1 to 3.
No, in beginning 1 to 2, after completing all left side, we will back to 1, visit 1, and then we will come to the right child. No, we shouldn't write. First you should come to 3. See here how the algorithm is there. When you come to 3, you should go to left. That is traversing here. You see the first statement. What is first statement? It's not printing. Visit means printing. Are you getting?
Okay.
I will do another one tree. You will get a still good example. Yeah. You take another tree now. You still. I'll write here 1, 2 this time, 3, 4, right side I will leave now 5, and this I will write some 6, and I will write only 7. Now take 3 node means, hello, 3 node means, speak 3. For one, for one, 2 is there. I didn't get that. See, binary tree means at most you should have only 2 childs. That's not a binary tree at all. No, pa, that is not at all a binary tree. See, this is binary tree traversal. Binary tree traversal means you can traverse only with a binary tree. What is a binary tree? The binary tree is a tree where the root will have at most 2 children. At most means 0 children can be there, 1 children can be there, 2, not more than 2. If it is more than 2, then it's not a binary tree. In beginning only I told. Are you getting? Are you getting?
Yes, sir.
Right. Now back here. So now in order, how you are going to apply the in order? Observe carefully now. I will put a dot. You follow the dot. I am at 1, right? So traverse to the left of left subtree. Then I will come to 2. Now my tree is 2, 3, 4, 5. Now again I should go to the left. Why? Because this is a recursive. Now I will come to the left. Now observe carefully. Now my tree is only 3. Now here what is the left tree? Traverse the left tree. Nothing is there. Nothing is there means, so I will come to the next statement, that is visit 3, right 3. Right? Now what is the next statement? Traverse right to the tree, that is 3 right side. Nothing is there. Now you will come back to the called function, which is a 3 is called by 2. Now you come back to the 2. That means in while calling from 2 to 3, the first traverse, left traverse is over, left out is right. Next statement is visit 2. Now visit root. Next, the right part you are going to consider. Observe carefully. Now right part. What is the right part you are going to consider? That is 4. You come to 4. Now 4 is having again the left child. Yes, 4 is having left child. Come to 5. Now here 5 is having any left child? No, 5 is not having any left child. Now come back to root. Now visit root. That is 5. Check for 5 any right child is there. No, no right child is there. Now go back to 4. Number 4 already you have gone left completed. Now visit 4. Then afterwards check any right child is there to 4. No, no right child is there. Now again go back to the called function. Means we will come back to the 2. Entire 2 subtree has been visited. 4 dots are there. Now go back to the 1. Now visit 1. That means visit root. Now come to the right of the root. That is 1. When you come to the right of the 1, what is there? 6 is there. Now come to the 6. Now check any left is there. This is important. Check any left is there. No, no left is there. Then visit the root. Root is 6 here. Yes, visit. Now check any right is there. Yes, right is there. Now you come to 7. From 7 check any left is there. No, no left. Now visit root. That is 7. Now check any right is there. No, no right is there. Now come back to 6. 6 is already visited. Come back to 1. Now all the nodes has been traversed. That is, what is in order? This is in order. That is 3, 2, 5, 4, 1, 6, 7. For above tree. Any doubt? Any doubt? If you practice, you will get an idea. If you are getting any doubts after practicing also, in the next class, definitely you must ask me. Why? Because this is almost all definite question which will be there for an exam. In exam also you have to do like this. You have to write stepwise. Here I have written directly. You have to write stepwise. Starting the root node is 1. Like that you have to write. according to the in order algorithm, traverse to the left tree, that is the left to the 1 is 2. Next, step 2, traverse 2. 2 is having again left child, that is 3. Come to the, move to the 3. Next 3. 3 doesn't have any left child. Back to the second step, that is visit 3. Write down 3. Next, any right child is there, no right child is there. Back to the called, the parent, that is 2. 2 is having any right child. Yes, like that you should trace. If you trace like that, you'll get. Otherwise, writing a tree here, you can trace with 1 like that, giving 1, 2 like that, you can trace. Not a problem. So you have to keep that in mind. Right? So in this way, if you trace almost all, you will get a good marks. Any doubts, you can ask me. Any doubts is there? So next class, tomorrow, I will I will move with this binary tree traversals. That is the next one, pre-order and a post-order. After this pre-order and a post-order, this will comes to end. We will go to the decrease and conquer method. In a decrease and conquer method, we are going to discuss insertion sort and a binary bed first search, that is BFS, remaining all, that is topological sorting. DFS has been completed. Then afterwards we'll go to the greedy. There distress already discussed, Kruskal already discussed, left out is prims. That means only 3 algorithms is left out now. So if we discuss the 3 algorithms, it will end the 5th unit. So any doubt is there, you can ask me, and remaining classes whatever will be available, I will keep for a revision. So then you must go with through the questions what I have given to you. Definitely you practice, you have to practice that particular questions. Right? Just 1 minute. Now I'll stop sharing this. Just I'll tell